Before you continue watching, pause the video, take a look at this question, and figure out your answer. This is probably something you've seen time and again. It's something that you probably know the formula to. We're asked to find the sum of all the numbers from 1 through n, and there are a lot of ways of going about doing this, and one of them is, of course, just knowing this formula. The sum is just n times n plus 1 divided by 2. Now, there are all sorts of ways that we can derive this. One of the most famous ways is probably this one, where you line up the numbers 1 through n, and then you line them up in the reverse order, something like this. And then what you do is you add them like this. Okay, so let's see what we get. We get 1 plus n, that's n plus 1. N minus 1 plus 2, that's n plus 1. And then 3 plus n minus 2 is again n plus 1. And so we keep on getting n plus 1, right? But how many times do we do this? We can just write this as multiplication, right? Well, there's 1 pair, 2 pairs, 3 pairs, all the way until n pairs. So there are n of these. So it's n times n plus 1. But remember, we added the same thing twice. So we have to divide by 2. And that's our answer. N times n plus 1 divided by 2. That's pretty famous. That's pretty easy, even, you might think. But what about something a little bit more complicated? Right? Instead of doing 1 plus 2 plus 3, what if we look at their squares instead? And so that question would be something like this. 1 squared plus 2 squared plus 3 squared, and then all the way until plus n squared. Now, again, if you've seen this before, maybe you know the formula, and maybe you don't. But here's what the formula says. So it's n times 2n plus 1 times n plus 1 divided not by 2, but by 6. And this is already a lot more complicated than what we saw. Right? The original thing we saw was n times n plus 1 divided by 2. This is the same thing as that multiplied by 2n plus 1 over 3. Right? We've got this 2n plus 1. This has been multiplied by 3. So it's a fair bit more complicated. And unfortunately, there's not really an easy way of coming up with this answer. Right? It's not so pretty. So how do we still understand this? How can we try to memorize this and really understand the reason that it does work? Well, for that, we have to use summations. Okay, and so in case you're not familiar with it, instead of writing something as 1 plus 2 plus 3 or 1 squared plus 2 squared plus 3 squared, I can also use this little notation over here. So this over here is the sigma, and it's essentially just the summation operator, right? So of course you're familiar with the plus sign. This is when you're adding two things together, and its analog in in higher mathematics is this sigma over here. And this is used when you're adding more than one thing together, when you're adding lots of things, maybe even infinitely many things, right? And how does this work? Well, over here, you're going to put on the number that you start with. Okay, so let's say you put I equals 0. I is a very common thing to put. Sometimes you can put k, you can put anything that you'd like. So I equals 1. That means you start off at 1, and then you finish off at some particular number. Maybe you stop at 10 when I equals 10. Maybe you stop when I equals 100. Or maybe you stop when I equals n. Okay, so this is I equals 1. We're going from I equals 1, I equals 2, I equals 3, all the way until I equals n. Now, what do we put over here? Well, over here, we put what we're summing. So if we put I over here, what would this be? Pause the video, think about it. From what you understand, write out the first few terms. Well, this would just be 1 plus 2 plus 3, right? Because I equals 1, I equals 2, I equals 3, all the way until plus n. But we can, of course, make much more complicated things instead of just an I over here. And so if we just make this I squared, we're going to have 1 squared plus 2 squared plus all the way until n squared. This is what we just explored over here. And it's a fair bit faster to write this than it is to write something like this, especially when the pattern might not be so clear and you want to make it explicit over here and just specify what the pattern is. Right? Maybe we were doing something like I plus 1 squared times I minus 2. Then you wouldn't really want to write out the terms because someone would have to figure out the pattern and then continue it themselves. So just a more compact way of doing it. Even if it seems unnatural for now, that's probably just because you're not used to it. But once you do get used to it, it'll become a lot more natural for you. Now, let's actually explore how we can use this. Okay, and so to do that, we're going to start off, I'm going to switch colors now, and we're going to start off with a simple example, something that we've already seen, and that's just this, right? We already saw this. This is going to have an answer of, well, you pause the video, type it in the comments, or at least think about what the answer will be to yourself. Okay, hopefully you pause the video. I'm going to give you the answer now. We just showed this, right? You just need to recognize that this is the same question as earlier, and it's got this answer over here. Now, how do we find this though? Well, we can write it like this. And now we're going to start using some summation properties. So there might be a few that you aren't familiar with. It's usually pretty natural to pick these up because they're very similar to what you might expect. But in case you're not, just watch through this and then we're going to move on to the next slightly more complicated part thereafter. So we know we have I over here, and I is the same as I plus 1 squared minus I squared. What does this give us? Well, this gives us I squared plus 2I plus 1 minus I squared, so that's 2I plus 1. So we can subtract another 1 over here, and then we can divide by 2. Okay, so I've just put a lot of brackets over here just so you see exactly what's going on. You, of course, don't need these many into your life. In fact, I'll just get rid of this. And it looks much uglier, a lot harder than what we've done, but you're going to see why it makes sense very, very soon. So, okay, let's see what we can do here. Well, we can take out the 1/2. So first we can take out a 1/2, and that makes it a little nicer to look at, but we're still, dealing with something pretty ugly here. You've got I plus 1 squared minus I squared, and then minus 1. Now, the minus 1 is a little ugly because it's not squared, or I mean, you could write it like this as well, but it should be pretty easy to deal with, right? If you're just adding 1 from I equals 1 to n, that's 1 plus 1 plus 1 plus 1 n times. So let's take that out now. And so I'm going to rewrite it like so. We have I plus 1 squared minus I squared. And then we have minus. Now be a little careful. Don't forget the 1/2 out there. But yeah, this is now what we have. And then it's minus 1. The reason the minus is over here is because I carried this minus over. Okay, so just pause the video. Make sure you understand this step over here because it might be a little bit of a leap. If you have any questions about it, make sure to comment them down below. And while you're scrolling down, make sure to also hit that subscribe button, okay? Because you've made it this far. We're almost at the big reveal. So we'll finish this off, then we'll get to the bigger and more interesting question. But if you stuck this far with me, then please make sure to subscribe as well. Like I said, this is pretty easy. This is just going to be negative 1/2 times n, so that's minus n over 2. And now we just have to deal with this over here. But this is not going to be so hard to deal with either, because we can do the exact same thing. Right now we take this out and now we write it like this. Okay, now the 1/2 is all the way out, so we don't need to put that back in over here. It's already there. And now we have I plus 1. No, sorry, not I plus 1. This is just I squared. Notice one thing though, right? If you take the first few values of both of these, you're going to see a lot of cancellations. And there are a few ways of going about doing this, right? You can plug in I equals 1. You get 2 squared minus 1 squared plus 3 squared minus 2 squared plus 4 squared minus 3 squared, blah, 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 and so on. Right? You can do that. That definitely works. But if you want to be a little bit more rigorous and less just, looking at patterns and seeing how they work, we can also just express this more mathematically. Okay, so give me 1 second. Remember, I is just an arbitrary counter, so we can actually just make it something else, right? What if we say that, hey, we don't want I plus 1 over here, we instead want, instead of I plus 1, we just want to make this I. Because if this is just I, then, okay, wait. If this is just I, then we can subtract, if this is just I, then this is the same thing as this. And then that'll make it much easier for us to see the cancellations. So let's see what we're going to get when we do that though. Okay, I've a little convoluted the way I explained it, but let's dive on it and see. So I plus 1. Let's say that I plus 1 is our new I. Okay, so we're just going to plug that in. Or actually, okay, no, let's just make it easy. Let's just say k equals I plus 1. Okay, sorry, I made this pretty complicated, but let's just say k equals I plus 1. That means k minus 1 equals I. And so our sigma on the left, we have k minus 1 equals I equals 1, so k equals 2. And then we're still going up. Now k minus 1 equals n, so this is going to go until n plus 1. And now over here we have just k squared minus this over here from I equals 1 to n of I squared. All right, what can we do now? Well, it's not that bad. Now we know that k, again, it's just a name, right? We can just make that I, we can just take it back into I, and that's completely acceptable. The only reason I switched it was because I didn't want to write this, because this might confuse you, because it's wrong, right? Like it's not a real thing. But anyway, we can do that now, just in a second step, so it's hopefully a little cleaner for you to see. And now over here, we can take the first term, that's going to be minus 1, and then we have this. And now, since we took out the first term, we plugged in I equals 1 by going from I equals 2 to n plus, just n, oops, n of I squared. All right, now what's left? Well, not a whole lot. We just have to, all right, yeah, so let's see, where are we now? Well, we can now also take out, similar to what we did here, we can take out the last term of this. So that's going to be with n plus 1 squared. So now we've got 1/2 times the summation from I equals 2 to n of I squared. Now we're going to regroup it a little bit. We get this. And then we have plus n plus 1 squared minus 1. All right, not too bad. And now look at what we have here, right? Look at what we have here. We can simply cancel this out with this. And that's the more mathematically rigorous way of doing what we said we would up here when we noticed all the cancellations. I erased it, but when we had all those cancellations happening. And so now we've got 1/2 times n plus 1 squared minus 1. That's not all though, because remember we did have the minus n over 2. So don't forget about that. And what does this give us? Well, you just have to do a little bit of math over here. It's not that bad. So 1/2 times, you can expand the whole thing. This is going to give you n squared plus 2n minus n. So that's 1/2 times n times, well, okay, n times n plus 1. And as expected, that's n times n plus 1 over 2. Now, we've done this. We're almost out of time because my timer only goes under 15 minutes nowadays. So let's see, what do we want to do now? I'm not going to finish the whole problem. I'm only going to do most of it and leave the last few steps for you to figure out on your own. But we're going to follow a very, very similar approach. So we're going to go from I equals 1 until n. And now we want to get k squared. So we're going to do I plus 1 cubed minus I cubed. Okay, it looks ugly like this. Let's just remove the brackets. Minus I cubed. And what is this going to give us? Very quickly do the math. It's going to be I cubed plus 3i squared plus 3i plus 1 minus I cubed. This is just 3i squared plus 3i plus 1. So what do we want then? We want to isolate the 3i squared part. And so let's plug that back in now. Oops, okay, yeah. So we've got 3i squared plus 3i plus 1. And now what do we want to do here? Well, we can write it like this. And then what's the last one going to be? Well, that's just going to be n again, right? We already know how to do this. We just figure that out. So this will be 3 times n plus 1 over 2 plus n. So that will just be 3n times n plus 1 over 2 plus 2n over 2. And we don't need that there. And now to proceed, we just have to figure out what this is, right? And what is that going to be? Well, we're going to follow a similar process to what we did earlier. And yeah, so now let's take this, right, and let's rearrange it a little bit. So what is that going to give us? We're almost out of time, so you're going to have to finish this off on your own. But if you have any questions, just ask in the chat. We're going from I plus 1 cubed over here. Okay, let's do the math here then. We're going to first make this like I equals 2 until n plus 1 of I cubed minus 1 minus this. And this is I cubed. And I'm not going to finish it off all the way, but just scroll up, pause the video, and see what parts you might need for your own proof. But I want you to finish this off just so you can get the practice yourself. Now we get n plus 1 cubed, and then we have just what we want, I equals 2 to n plus 1 of I cubed minus the exact same thing. And then minus 1, and these cancel out. And so now we've got n plus 1 cubed minus 1 is equal to, go up and see what we had. This is going to be equal to this over here. So you just want to isolate and solve for this, and you'll get the final answer like that. That's it for this video. Hope you enjoyed. Make sure to subscribe. Bye bye. Thank you so much.